Good day and thank you for joining us. In today's lesson, we'll be looking at factorization, all the different types of factorization. We'll try and get through quite a few examples so we can get through as much diverse questions as you can encounter when writing your tests. So straight off, we're going to start off with some common factor, okay? So looking at this, we're going to go for our first example now. So we have 2a minus 6b. So when we're doing common factor, it's exactly that. It is looking for the common factor in the expression, okay, or in the question. So we're going to be looking for the highest common factor by number and then by variable, okay? So what I mean by that is we're going to look at the number first, okay? What's the highest common factor here when we're looking at the numbers? The highest common factor here is going to be 2, right? Because 2 goes into itself and goes into that negative 6 over there, right? So what we're going to do is, first we take out that 2. Now we look at the variables. Is there any common factor? No, because this is an a and a b, so we can't take out a variable, right? So all we're going to end up taking out is this 2. And what does taking out mean? Basically, when we are taking out, we're going to be dividing the old expression by what we've taken out, okay? So what it looks like is 2a over 2, because we took out that 2, remember? So we're saying 2a over 2 minus 6b over 2. And ultimately, that's what's going to get us our answer. So it's going to be 2 divided by 2. So we know we left off with a over here. And then the 6 divided by the 2, which gives us 3 over there, right? So this is 3b. And that is our final answer. And this has been factorized using common factors. So final answer is 2, open brackets, a minus 3b. And all we did was take out the common factor to factorize this expression, okay? Moving on to the next example, we have 2x squared minus 4xy. So once again, what we'll be doing first is looking for that common factor in the numbers, okay? The highest common factor here is going to be 2 once again. Now we look at the variables, okay? So we can see we have an x here, but we also have an x here. We only have a y here, but we don't have a y over here. So we know that the only variable we're taking out is x, right? So we have an x squared here and 1x over here. We can't take out an x squared because we can't divide x by x squared. So what we're going to end up doing is only taking out the x because that's as high as we can go, right? That's the highest common factor in the variables, which is going to give us x, okay? So we're taking out that 2x. And that is all that we're taking out from this expression. Once again, we'll come over to the right-hand side here just to see what's happening. So what's happening here, this is going to be your bracket answer. It's 2x squared over 2x minus 4xy over 2x. Okay? So that's all we're doing. What we took out, we're dividing that into the expression, right? So that 2x is going to cancel out there. That 2 is going to go away. This x here is going to become x to the power of 1 now, right? And then this 2x is going to come in here. It's going to change this into a 2, right? So what's left over now is x minus, sorry, that x also gets cancelled out over there, okay? X minus 2y as your final answer there, okay? So that's all we're doing. We're dividing 2x squared divided by 2x leaves us with just x. 4xy divided by 2x. That 2, the 4 divided by 2 gives us 2. X divided by x gets rid of that x, and then we left with that y, leaving us with 2y. Cool? Moving on to dots now. Moving on to the third example here. We have been given here 3a minus b minus c a minus b. So now you're looking at this and you're wondering where is the common factor, right? Now, one thing that we need to note when we're doing factorization, or when we're doing anything for that matter, when we have brackets, they can be regarded as a term, okay? Or part of a term, right? Because remember now, this whole thing over here is a term, okay? This bracket with a minus b is just part of that term. And if we look at it like that, as our brackets being our variable, we can see that we have two common brackets in this expression, okay? And what does that mean? we can take out the common factor as the brackets. So what ends up happening is we take out that a minus b, and now what we are left over with, now remember we're dividing this whole term over here, 3 open brackets a minus b, over, we're dividing that by a minus b, okay? So which means that a minus b is going to disappear, which means we are left with 3 over there, minus, and the same thing's happening here, minus c, right? So you can see that all we have to do is take out that brackets, and then we just write in what's left over, that 3 and that minus c. Now we can move on to dots, okay? Our difference of two squares. So looking at our first example, so we can dive right in. We have x squared minus y squared, okay? So important thing to notice when we are dealing with dots, this is always going to be a negative sign in between, okay? If it's a positive sign, you can't work it out when it comes to difference of two squares. Another thing with difference of two squares, we can identify it by seeing that we have perfect squares, okay? So we have an x squared here and a y squared here. So those are perfect squares, but I can obviously better represent it when we have proper numbers in front, right? Then I'll show you guys what I mean by perfect squares. So we have x squared here minus y squared. So the way we're going to set this up is we're going to open up our two brackets. And so what you're going to do is you're going to write in the square rooted version of this x squared and this y squared into the brackets, okay? So if I write that in, I have x and y. X and y. All I've done is I've written out the square rooted version in the brackets. And then what's happening is we're saying plus and minus, right? Because remember, to get that negative sign over there, we have to have a positive and a negative, okay? Because to make that y squared, it's a positive y times a negative y, which is going to give us a negative y squared, cool? And it will always be that type of setup when it comes to dots, with your one brackets being positive and the other one being negative, okay? Moving on to the next example here, we have x squared minus 1 over 36. Okay, cool. So this is a bit of a different example here. But if we can look at this example, we can see once again that there are perfect squares here, right? What do I mean? 36 is a perfect square. The reason is because if I square a number, I'm going to get to 36. I square 6 to get to 36, making 36 a perfect square. Cool. And that only applies to numbers that can be found by squaring a different number. Cool. Same way, x squared once again is still a perfect square. So what's going to happen once again? I'm going to have my brackets open. Now I'm going to write in the square rooted version of these numbers that are over here. So I have x, right? Now we have 1 over 36. Now, just because it's a fraction, don't let that ever confuse you, okay? You're still going to get the square root version of all of these numbers. So, square root version of that 1, it's still going to be 1. Square root version of that 36, we know is 6. So there we go. And then obviously your normal setup, you have plus and minus, or minus and plus, doesn't matter which order. And just like that, we've found the difference of the two squares when coming to these as a fraction, okay? So the fractions really aren't that complicated. All we're doing is finding the square root of top and bottom. Then here, moving on to our final example of difference of two squares, we have x minus y squared minus 9. So this is sort of a curveball that they try to throw you to confuse you. But remember now, when we are dealing with these brackets, we can regard that bracket as that one term, okay? So what we are saying is that this brackets x minus y squared in brackets, right? We're going to count this as one term, and this term is being squared. So we know now that the same way if we're looking at x squared, this is how we're going to look at this bracket, okay? So if we're looking at that the exact same way, if we square root this bracket, what will be left over with is x minus y, okay? That's what we left off with. X minus y. Oops, sorry. So we've square rooted the brackets now, and we got left with x minus y. And then we're going to square root this number over here. We get 3 and 3. And that's obviously going to be plus and minus. Cool? And just like that, we find our final answer, okay? So that's all that happened with the brackets, okay? The brackets fell away when we square rooted the brackets, cool? This is what ended up happening. So it wasn't a case of timesing out this and then getting that, okay? We just need to square root the bracket. What that ultimately did was get rid of that square, and we just left with that x minus y. So it's really not that complicated when it comes to brackets. Don't get intimidated by it. That's all we need to do. Moving away from dots, now we're going to move on to trinomials, which most of you should be very familiar with. So looking at the first example here, we have a squared plus 7a plus 10. Okay. So we're going to go with our general setup and the rules that we always try and follow. So we're going to set up here with a times c and b. Okay. So what this means is a times c, we know that the general setup of a trinomial is a squared plus, so we know that this first term here is going to be the a, right? And we know that the second term over here is going to be b plus c, okay? So we have ax squared plus bx plus c, right? That's the general setup of our trinomial. So we know that the first term is a, the last term is c. So we're saying a times c. So remember there's a 1 in front there, so it's a 1 times 10, so we have 10. And our b is 7. So looking at this, we need to figure out what can I times to get to 10, but also using the same numbers add to get to 7. And after looking at different possibilities, you'll eventually get to 5 times 2 gives me 10, and 5 plus 2 gives me 7. So you can see there, I've first did a times c and then b. So I got these answers. Now I need to say what can I times to get to 10 and also add to get to 7. So what that does is we can open up our brackets here. Because that starts at a squared, we say a and a right up over there. Then what's going to happen is we going to put in these numbers that we found, right? We found out that it's 5 times 7, 5 plus 2. So what we're going to do is use this part over here. Okay, so we know we have a positive 5 and a positive 2. So we'll say positive 5 and positive 2. And just like that, we factorize using trinomials, okay? The trinomial rule. Moving on to the next example here. We have a squared plus 5a minus 6. So once again, we can set up a times c, b. A times c in this case, 1 times negative 6, we get negative 6. And then b being 5. Cool. Remember now we need to times to get to this negative 6 and add to get to this 5 using the same numbers. And the numbers you'll eventually get to is 6 times negative 1. And you can see 6 times negative 1 is going to be negative 6. But also 6 plus negative 1 is going to give me that 5, right? Because that negative 1 is going to minus from that 6, and we're going to be left with 5, right? So once again, we can come over to our final step here. We say a and a. And then we bring our terms over from this over here. We have a positive 6 and a negative 1. So we say plus 6 and minus 1. And just like that, we've fully factorized this expression as well. Moving on to the last trinomial example now. We get given 3p squared minus 9p plus 6. Okay, so we're going to set up this again. A times c, b. So before I carry on over here, I'm just going to come back here. You can see now we have a 3 in front of this variable, right? Which we haven't encountered in the previous examples. So how you're going to set up for this is you're just going to write down here 3p and 3p. And I'm going to show you how that's going to work out in the end. Because obviously we know 3p times 3p is not going to give us 3p squared. It's going to give us 9p squared. But we will deal with that once we finish up here on the right hand side. So a times c, 3 times 6 is going to give us 18. And we have negative 9. Okay? So what's going to give us this? We can see that middle term over there is a negative, okay? and obviously that gave us this negative 9 over here. So the best way we can do this is negative 6 times negative 3, okay? So this is just going to be trial and error, you trying to figure it out, okay, on a piece of paper or something. And you're going to times them, and you're going to see negative 6 times negative 3 will give me 18. Positive 18 because that's a negative times a negative, okay? And negative 6 plus negative 3 is going to give me negative 9, right? Because that's negative 6 minus 3. So we're going to take these terms, remember these are both negative now, so it's minus 6 minus 3. And so what we're going to do from here is we're going to take out a common factor from one of the brackets, okay? So we'll keep this first bracket as is, and I'll take out a common factor from this second bracket. And what that's going to be is 3, okay? And we're left with p minus 1. Because remember, when we take out, we divide the terms. So 3p divided by 3 gives me p. Negative 3 divided by 3 gives me negative 1. Once I've taken out that common factor, all you're going to do is scratch out that common factor, okay? It's gone now. And what you're left over with is your final answer, okay? 3p minus 6, p minus 1. And that is the final answer over here. And don't worry about the principle behind taking out that scratch. That we just have to do, okay? Once you take out the common factor, get rid of that. And then you're left with your final answer after that. Cool. Now we move on to grouping, okay, which is the final section that we'll be covering now this morning. So let's get our first example out here. So we have 2a squared minus 2a minus ba plus b. Okay. So looking at this example now, when it comes to grouping, what we are trying to do is form sort of, remember, if you can remember when we're looking at common factors and we had those common brackets that we took out, that's basically what we're trying to get over here. We're trying to form brackets that are common, okay, by grouping terms together that can be, how can I say, factorized by getting common factors, okay? So basically what I'm trying to say is, if I look at 2a squared minus 2a, I can take out a common factor from there. If I look at negative ba, let me just do a different color there quickly. If I look at negative ba plus b, I can take out the common factor there, okay? So that's basically what you're going to try and do, okay? So I've identified I can take out a common factor here. So what I'm going to do is I'm going to take out that common factor, okay? So 2a squared minus 2a. So what I'm going to take out here, in this case, is going to be 2a, right? That's the highest common factor I can take out over there. And I'll be left off with a minus 1. Now let's see here on the right hand side, I'm going to take out the common factor here as well. Okay, so I'm going to take out minus b. And if I divide that in, it's going to be a minus 1. So you can see by grouping the correct terms together, by taking out the common factor, I can make the exact same brackets on both sides of the equation or the sum, okay? And once I've done that, we can see that there's a clear common factor in the brackets. So what happens is we take out those brackets from the entire expression, okay? So that's what's happening when we're doing this common factors brackets. We're taking out the brackets from the entire expression. And then what we know is we're left over with that 2a minus b. Cool? Because we've divided 2a minus 1 by a minus 1, so that a minus 1 cancels out and we just have 2a left and minus b. So we're just filling in what's left over. Then looking at our final example, we have 4a minus 3b plus 6ab minus 2. So here's a case where we need to try and get our expression to a point where we can start to group the expression, the terms together, okay? Because if I look at the setup right now, I can't pull out the common factor between these two, okay? But I can find a common factor for this one, obviously. But the whole point is that we need both sides of the equation to be able to pull out a common factor, okay? This 4a minus 3b, I can't pull out a common factor over there, right? Not in numbers, not in variables. So what I need to do is set up the equation in such a way that I'm able to do common factors, okay? And the way we're going to do that, so we can see that 4a and this negative 2, a clear common factor can be taken out there, and negative 3b plus 6ab, a clear common factor there as well. So what we're going to do is put those two together. So we have 4a, we can bring in that negative 2 to here, and that's minus 3b plus 6ab. Okay, so now looking at this, we've successfully grouped the terms together that can be taken out with a common factor. So what ends up happening now is we're going to take out the common factor on the left hand side, so we're going to take out that 2. So what we're left off with here is 2a minus 1. Okay, and then here on the right hand side, we're going to take out that negative 3b, right? 3 being the highest common factor here in numbers and in variables b. Okay, once we've taken that out, we'll have 1 minus 2a. So now we can see that we have a bit of a situation where the brackets aren't actually the same. Where these two terms over here, 1 minus 2a, should be 2a minus 1. So a very quick way we can solve that, I'm going to show you guys a magic trick, okay? This time it's free, you can use it whenever you want to, okay? So what's going to happen is that negative over there, you're going to change it to a positive. And now what you're going to see, what ends up happening to everything after the positive. So 3b stays as is, but this brackets changes immensely, right? What happens to the brackets is these terms switch around. So you can see what was 1 minus 2a. Because I changed that sign before this term over here, I changed the brackets where we now have 2a minus 1. And just like that, we are left off with having two brackets that are exactly the same, which means we can take that out as the common factor for the expression. So we take out 2a minus 1, and then we are left off with 2 plus 3b. Right? That 2 in front of there plus the 3b in front of there. And just like that, we've successfully factorized this whole expression over here using grouping. Well, anyways, that's going to do it for today's recorded lesson. Thank you very much for joining us.